So welcome to Security Automation for Enterprise IoT via intent-based networking. Anyone ever hear of that before? Intent-based networking? Got about another 5–10%. So intent-based networking is going to introduce levels of automation in the service lifecycle, and we're going to take that intent-based networking concept. That's the underpinning concept to our strategy, and actually, frankly, most of the solutions that we had created in the past 2 years. So we're going to take that intent-based networking concept and combine it with cybersecurity to address use cases in a more efficient manner. We see this new hybrid cloud design start taking place. The building blocks, you're going to hear me say these terms a lot. I just want to make sure that we're on the same page with these terms. Consumer is where the app or the user is. Provider is wherever the application is, regardless if it's private data center, internet SaaS, or pub cloud. And we're using that cloud edge, or customers are using this cloud edge to bring the consumer and provider together. So if we look at the two topologies for a moment, side by side, on the left side is that backhaul access, how we were designing networks for the past 2 decades, where you take your app, you put it in your private data center. If you look at the right, that data center is just another application provider off this application provider wheel that we're calling the cloud edge. So you're purchasing, you're buying the flexibility of choice. You consume your app wherever you want and don't have to worry about inefficient traffic patterns or transport costs. So we take what you're trying to do at the top, that policy, which was the intent we just talked about on the prior slide. We express that into an SDN control point at the top, which translates the what into the how and starts instantiating your services, deploying your fabric on your infrastructure. Now what we're doing is we're deploying, operating, and retiring workflows, people, places, things, apps. All of this was, or 80% of it, was being done manual. So now we're creating templates for you, putting them in the SDN control points, so you have to fill out the templates and it will do this for you. Now we're halfway around, we just instantiated the fabric, the services, et cetera, but how do we know our intent is being maintained? So we light up telemetry on the infrastructure, get a view into everything we're using. How is the network behaving? Once we have a view into it, we can start tying actionable responses to it, feed it back into the SDN control point. This is what we call intent-based networking loop logic. We're creating an intelligent closed loop framework, if you will. We developed this 4-step strategy. We call them digital principles. The first one is integrated architecture. Second one is zero trust. The third is integrated assurance and threat detection. And the last one is dynamic security protection. Now we're just going to walk through each of these so you can see how this starts applying. So how many here have heard of zero trust? How many here are implementing a form of zero trust? And okay, a fair amount, great. So there's been some evolution with regards to how this has been working and what the new perimeter security goals are. So provide secure access from any trusted user to any trusted device to any appropriate application. We got some words there that are italicized for a reason. Is let's first examine the user. We're going to have an API into whatever identity database that you're going to be using. Let's say Active Directory, LDAP, et cetera. We want to confirm that this user should be on our network. They have an active account in Active Directory. Leverage multi-factor authentication capabilities, because even if you have credentials, those could be stolen. So how about some out-of-band multi-factor authentication capabilities? Now, in parallel, understanding the device security is as important, if not more important. So same type of access here. Querying a device inventory, whether it's an MDM, like Mobile Watch, Zenprise, or Jamf, or whatever you're using for your endpoint database, to first find out, is the device ours? Is this a company device? If it isn't, is this maybe something the person brought from home? Secondly, what is the security posture of the device? So using APIs into safety net, into Apple to say, does this device's security posture conflict with the policies that I have to gain access to these applications? Now they take these 3 variables, pump them to a cloud policy engine, which has got a single admin console for it. Now the cloud policy console is going to look at the user and the device and say, does this match for, let's say, to gain access to a private app, let's say Outlook? How about a public application like Dropbox or Salesforce? So you can have, all three have got to be in concert. The user, the device, and then comparing that against what the application is expecting. So this allows us to start veering and eliminating borders. Now, most companies aren't borderless, they still have borders. So the traditional approach, the three main ways, if you have your networks that you administer, that one would gain access to a network, wired, connecting into a wall, or wireless, connecting to an SSID, or coming in from the remote access outside. We take those three and front end it with a policy engine, connection over radius. So we can answer the who, what, when, where, how for the device, and then based on that information, we create that tag, and then that tag, we share it. We share the tag with our own solutions, with third-party solutions, so they can use all of this information that we're collecting. The third step, integrated assurance and threat detection. So we're coming around the loop. Now we're going to start using the telemetry for the last part, tying actionable responses to it. So I don't know does anybody work in a security operations center here? So many have these questions, whether you work in a security operations center or not. Is this bad? Did it affect us? Where is this? How did this come in? What is the scope of the problem? Against the technologies that you see on the right-hand side. Now what we're doing is we're trying to aggregate and correlate all this information across all of these vectors, routers, switches, firewalls, IPS, web gateways, email gateways, so one doesn't have to pivot between all these consoles. Let's aggregate this information, pull it together. And here's a visual representation of essentially this concept. Is taking all these questions, pulling together all the event data and alert data from all of these different vectors, combining it with third-party intelligence feeds, our own intelligence feeds, threat intelligence feeds, and then presenting this to the customer visually. So to your SIM, if you're leveraging a SIM for more efficient forensic investigations, or teeing up the last point, which is dynamic security protection. We're doing all of this for a reason, right? Now this is the part that's constantly learning threat info and tying actionable responses to behavior. So as an example, what we're trying to do here is use all of this information to start automating your common workflows, your common scenarios. Network segmentation. So in the beginning, we talked about network segmentation from a NAC perspective. When you're trying to gain access to the network, let's look at the three gateways that one is coming in, wired, wireless, remote access. Point them to a policy engine. I'll answer the who, what, when, where, how, and then I'll push you a tag based on your access. What if you're already on the network? What if you're on the network and now we want to determine, are you going to do something malicious? If you do something malicious, what are we going to do about it? So in this type of scenario, you're already on the network and malware happens to find its way in. Now, since the network is integrated, all of the components are integrated in sharing information, that fires an alert. Once the alert fires, we can start tying an actionable response to it. So we invoke a flow through that policy platform to quarantine the user. So this could be an internet-only access VLAN, it could be a port shut, it could be a port bounce. It just depends on your security policy. This can be automated, it could be manual, but the point is of trying to provide the logic and the capabilities to the user or to the admins to begin extricating yourselves from these day-to-day scenarios that take up a lot of time, allowing the network to self-manage, self-heal. Another common scenario, breach response. Just about every customer has got to deal with this. So if malware happens to find its way in, past the initial lines of defense, let's say, since the network is integrated, it's going to detect it, fire an alert. Once the alert is fired, now we can tie an actionable response to it. If you happen to have an agent on your machines, on your endpoints, we can remove that from all of the machines. But in larger customers, they don't they've been a little bit hesitant to put an agent on all of their machines, and for good reason. I mean, if you have 20,000 endpoints, you may not want to do that. So instead, how about let the network take care of it for you? So since it's integrated, it's a see once, block everywhere type of approach. We saw this malware. We're going to send a signal to my network, my firewalls, my IPS boxes, my web gateways, my email gateways, that if you see this malware, if you see this file, if you see this hash, I want you to kill it so it doesn't traverse the network. My email address is in the presentation. I'd be happy to answer any questions you may have. And with that, we can conclude.